So I did it. I had my seventh graders told me I start all of my videos with so, and and I've been trying not to do that, and then I did it. We have been working on solving systems of linear equations, and today we're talking about solving systems of inequalities, so not equal, right? They can be equal, but for the most part, what we're dealing with is greater than or less than, right? They can also be equal to sometimes, like if they have that little line underneath, right? Then we can have equal to. The thing is if you remember when we've dealt with inequalities in the past, there's no one answer to an inequality, right? It's like a whole set of solutions when we're talking about solutions to inequalities, right? If I say to you that x is greater than 4, it means that x is everything that's bigger than 4, right? If I say that x or y is greater than or equal to 7, it means it's 7 and then every number that's bigger than 7 as well, right? And the same thing is true when we're dealing with graphing the equations of lines, right? If you look at these problems that I have here on this one little Delta Math sample, which I wish I could blow up a little bit, but I can't. I don't think I can. Doesn't matter. Here we have y is less than, right? We know it's less than because the little part is pointing at the y. Y is less than negative 2/3 x plus 5. That means whatever the graph of this looks like, y is going to be everything less than that. Does that make some sense? A couple things when we're dealing, notice that all of these are going to be set up in this y equals mx plus b form. Whether you have the equal sign or not, the inequality is still going to graph the same way, but with a few little changes, right? So I have this y is less than 2/3 x plus 5. And we know how to graph that if it's an equal sign, right? If it's an equal sign, we're going to find the 5, right? Because that is our b, that's our y-intercept. And so we're going to put the 5 point in, and then we're going to use the slope to count out our next point. In this case, our slope is negative 2/3, which means I can either go down 2 and positive 3, or if I want, I can go up 2 and negative 3. Doesn't matter which way I do it as long as I make one of them negative. Now, that is the graph of this line for the most part, but this line says that this is just less than, y is just less than that, right? It can't be equal to it. So when that happens, you're going to hit change line and it'll give you a dotted line. So if it can't be equal, you want the dotted line. If it can be equal to, you want a solid line. That's the difference. That's like your open dot, closed dot, right? You're going to have a dotted line if it's less than or greater than, and you're going to have a solid line if it's less than or equal to or greater than or equal to. So here we've got the graph of this line itself, and it's saying that y is less than that. That means everything under this line is what that can be. And so we're going to hit change shade, and it shaded the part we want, right? Everything under that line is shaded, so we're going to leave that shading the way it is. If it was in the wrong spot when they brought it up, we just hit change shade and it'll take it to the next one, right? This is why I wanted to do it in Delta Math, because all the work kind of gets done for you. But we know that it is less than. Y is less than that, so we want everything under that line to be shaded. Now we're going to graph our other line. We have y is greater than or equal to 4/3 x minus 1. So we know that that minus 1 is our y-intercept. So we're going to go and we're going to make a point at negative 1. And then we're going to use our slope of 4/3 to find our next point. Remember, it's rise over run, so we're going to count up 1, 2, 3, 4. And then we're going to count over 1, 2, 3. Now this line for us is going to stay solid because it does have that equal to line underneath it. And you can see here now it brings up line 2, the second one that I graphed. So if that's the one I want to change something on, it's good. If I want to go back and change line 1, I can select line 1, right? But we are working on line 2. And we know the graph is right. We don't need to change the line. So we are going to go ahead and we're going to change the shade. Now look at this. This is greater than. That means our y's are getting bigger with every x, right? So it's going to be this part. If they gave me the other one and I hit change shade, it's going to do the less than. But we want it to be greater than. The important thing is the solution when we're graphing these things is this area where they're both shaded together. So the solution set that works for these two inequalities is the area that they have in common. Does that make some sense? So like this part isn't a solution, right? This green part up here isn't a solution and this purple part isn't a solution, but this like grayish blue part is a solution, right? Everything in that grayish blue area is a solution to both, makes both of those true. So where it says point, I can pick any point, list in this gray area for my solution. I can pick 0, 0 if I want, right? Because 0, 0 lies inside that blue-gray area. I could pick negative 1, 1. That's what I'll do. I'll do negative 1 and 1. Doesn't matter as long as it's some point that lies within that gray-blue area. Okay? Does that make some sense? I'm looking at the only face I could see, which is Lance, some kind of a recognition that is vibing with you. And when we submit the answer, we should get a check mark on both of those. Now notice it says that there's many other possible points. Anything can be true as long as it lies in this gray-blue area. Now, had I put in, 2, -2, I'd have gotten the whole thing wrong, right? Usually, though, I believe it will tell you what you got wrong. Maybe I will work on getting one wrong. It's hard for me to just submit a wrong answer on purpose. I swear I want to sometimes, but it's really difficult to do. Notice again, we've got a new problem, but it's set up in that y equals mx plus b form. I tried to find some that were going to make you work a little bit on this, like make you reorganize it. Lucky for you, Delta Math doesn't have any. They don't have any harder than this. So that's good though, because this isn't about whether or not you know how to graph equations, right? You guys have graphed equations before. And we really want to deal with these inequalities anyways. So the main focus is going to be on like which ones have the dotted lines. Are you shading the right area so that you're not thinking so hard about the graph of it, but you're thinking about like the positioning of it, like what are our solution sets. And if we look at this first problem, it says we've got y is greater than 3x minus 4, right? So we know that whatever line we get, the solutions to this particular problem, the top part, are going to be everything above that line, right? It's not greater than or equal to, so we need a dotted line instead of a solid line, right? So let's go ahead and we're going to put in, we know our y-intercept is -4, and that our slope is 3. And if our slope is 3, that's the same as saying 3 over 1, and it's our rise over our run, so we're going to go up 1, 2, 3. We're going to go over 1, and we have the graph of that line. Now we know it can't be equal to, so we're going to go ahead and make it a dotted line, right? Because that means it can't be equal to anything on that line. Now, when we're talking about shading it, we're saying it's everything bigger. So we're saying y is going up from every point on this line, which means this side is going to be shaded, right? Because every y value is above right there, right? Of the purple. And so now we get the opportunity to go and graph our other line. Now our other line says y is greater than or equal to -1/2 x plus 3. So we know that our y-intercept is going to be right here at 3. And our slope is -1/2. So I can go down 1, +2, or I could have gone up 1 and -2. Notice that that would fall, if I go up 1 and -2, that would fall on the same line. Now, doing that, I went and erased my whole line. But so now I got to go back and put my line in. 3, down 1, over 2. But my whole point is it doesn't matter which way you go. Like, as long as you take either the rise and run negative or the side-to-side negative, it doesn't matter which one as long as you choose one of them, because it'll still be a point falling on that line. Now, this says that we are greater than or equal to, which means that we want that solid line there because it can be equal to. It means that we are including all the points that fall on that line. And it says that it is greater than, so it's going to be shaded in that section above the line. So we're going to hit change shade because nothing's shaded yet and see where it lands. And it gave us the part above, so we don't have to go looking for it, right? Had it been less than, we'd just hit change shade and it'd bring it below. And so our solution for these two problems is everything that falls in between these two in this gray blue area, right? Purple is the solution for the first line. Green is the solution for the second line, but that bluish gray is our common solution for both. And we're going to pick some point in there. Doesn't matter what it is. I'm going to pick 0, 6. I'm going to pick that point right there, 0, 6. Does it matter? No, as long as it's some point that falls in that blue-gray area. So I'm going to go 0 and 6. We're going to hit submit answer. It's not so bad, right? Sometimes you'll see a different sample point in there. If you get it wrong, let's go see what it looks like when we get one wrong. Let me torture myself. Let me torture myself and submit a wrong answer on this one. So here we've got our graph. We've got y is less than or equal to -6/5 x minus 4. So we've got our point at -4. And we've got our -6/5. I'm going to go up 6 and then -5. 1, 2, 3, 4, 5, 6. And then I'm going to go -5. This includes it, right? It's y is less than or equal to. But just for funsies, just to get it wrong, I am going to change the line to a dotted line. Even though I know it's a solid line. Because remember, I'm trying to get this one wrong. And it's torturing me already. I'm feeling the torment of submitting a wrong answer. It says that y is less than that, right? It's less than, which means our shading would be everything below that line, where everywhere where y is getting lower for every x. So it shaded the right part for us, right? Now we're going to put in our other line, and I'm going to go, okay, well, I've got 4, right? We've got 2/5 x plus 4. So 4 is my y-intercept, and my slope is 2/5. So I'm going to go up 2 and over 5. I hope I'm in the right spot there. It is equal to, and we're saying that this is bigger than it, so it should shade everything above that line. And so our point is going to fall right in this area, right? Let's pick a point on the line. Why do I want to pick a point on the line? Because I know it can't be a point on the line. Um, I don't know if any of these points are actually on, like I can't see where it lies, so we'll just deal with having the shade be wrong for now. And we'll pick some point within. We'll go -8, 2. That'll be our point. Now my graph is wrong on this one, right? Correct? Because I, -8, 2, because I made it a dotted line. And I just want to see how delta math deals with it being wrong. So we got an X. Let's see if it tells us why we got an X. Okay, so it does tell you. It says at least one of your lines is not correctly made as solid or dotted. So it does tell you what is wrong with the problem when you do it. I just wanted to make sure that it would tell you, because what are we doing? We're doing 3 things, right? We've got the graphing, or 4 things really. We've got graphing the line. Did we graph it correctly? We've got, is it equal to or not equal to, right? So is it solid or is it dotted? Did we shade it properly? And did we put in a point that actually lies within the common solutions? So there's 4 pieces to each of this, right? Did we graph the lines right? Did we get the equal to or not equal to? Like, is it dotted or is it solid? Is it shaded right, or do we have a point that lies within the solution set? And you can get any one of those 4 things wrong, and it's going to mark the whole thing wrong. The glory of delta math, though, is that you can get 100% on every single delta math, because you can just do another problem. I don't put any penalties in there if you keep going until you get, I think there's 10 of these, so until you get 10 correct, right? So there's no dings in that. You can always get 100%. Does anyone have any questions regarding any of these problems? I think I'll do this one more, and then I'll leave you to it, but let me know if you have any questions on it. Here I have my problems. Notice neither of these have equal to symbols on them, so both lines are going to be dotted lines. We're going to start at -8, and we have a slope of 2, so we're going to go up 2 and over 1, and there's our graph, and we are going to make it a dotted line. This y is less than, so it's going to be this little section over here. I don't know if you can see my cursor moving, but it's going to be that section where it's, luckily it just put it in there right where I wanted it, right? But my y's are getting lower under every value for x. Now we're going to do the same thing with this shading. We've got 4, right? And we've got a slope of negative, which just means -1. So I can either go down 1 and +1, or I can go up 1 and -1. It does not matter. I do, though, need to change the line to dotted, because it is also not equal to. And we're saying that this y is less than, so it's going to be everything underneath that dotted line. So notice it gave me above it. We need below. So we just hit change shade again, and it gives us that area below. And here is our solution, our gray-blue area. I am going to go with the point 4, -4, because I know it lies within that point. It says that I'm amazing. That's basically what it's telling you right there. It's like, genius, genius level. So does everyone kind of get what we're looking for on that? Did I put you all to sleep? I know a couple people are awake. I could see heads moving ever. Well, that is basically that all there really is to any of this. I'm going to stop recording because I'm so sick of looking at me.